Hey, Paul.
Oh, hi.
How are you?
I'm super. How are you?
Could be better, could be worse. So that's always a plus. Um, so before we go any farther, who be you?
My name is Paul Tchaikovsky, and I am a managed OpenShift black belt at Red Hat. And who, sir, are you?
Hello. My name is JJ Asgar, and I'm a developer advocate for the IBM Cloud. And I'm actually wearing a Red Hat t-shirt today, which is kind of cool.
Ooh, look at you.
And it's an actual OpenShift 4 t-shirt too, which is apropos because this is our Thursday stream where we do cloud native things, right?
Yes.
Yes. So, how about you just give us a little rundown of what you think we're going to be doing today?
Well, um, I heard on the grapevine
Mm-hmm.
that next week is a little conference called KubeCon.
Mm.
And it is a conference in which a bunch of nerds to get together and talk about Kubernetes. And as part of that, as usual, JJ, the man here to my left,
Right. Wait,
or right,
left.
right to us, left to them,
Yes.
I think. I don't know. Uh, has overcommitted himself and is doing a lot of things. And one of those things he's doing is an Istio workshop, a service mesh
Mm-hmm.
workshop specifically.
Yes.
And I said to JJ, hey, why don't you take me through your service mesh workshop? Because I know diddly squat about service mesh.
That's
And
a lie, sir. You know
JJ
a lot of.
said, JJ said, okay, I can do that. And that is, by the way, a perfect impression of JJ. Thank you very
It's true.
much.
That is true. I was nicknamed Eeyore as a kid.
I was
Um.
going for, remember in the original Warcraft,
Oh yeah.
I'm trying to
Job
remember, was
done.
it the,
Job
yeah,
done.
yeah, I was going for that voice.
Yep. Yep.
Okay.
Okay. Job done. But yes, so we that is exactly what we're going to do today. We're going to walk through the service mesh workshop that we were planning on doing in KubeCon, and hopefully, if you are watching this in the future, uh, if you didn't make it to the workshop, hopefully you'll learn something as we walk through this. Um, we should probably level set by talking about what a service mesh is before we go any farther. I can give my little TLDR, and how about Paul kind of fill in the gaps? And then when we actually play with the technology, if you've never seen a service mesh before, hopefully it'll make sense. So when you, so as you build up microservices, right, and you have a bunch of little microservices running around to run your application, you're going to have some visibility into what's happening between those microservices. You're going to need security between those microservices. You're going to need the ability to roll out microservices without breaking your whole application. So, Istio is a service mesh that allows you basically to have a control plane and visibility into those microservices to be able to know if you spin up a little application, you want 10% of your total traffic to go to that specific microservice to test a new feature, you can roll something out like that. You can also throw in SSL, intercommunication with secured communication there too, and the
Let's say TLS.
TLS.
It's a
Okay,
little bit more accurate.
yeah. And then you can also have the visibility, which is very, very important for microservices because you need to know what's actually happening. Now, Paul, what's a sidecar exactly?
Well, that is the question of the day. So you have the canonical unit of compute in a Kubernetes cluster is a pod. And a pod is one or more containers running in the same execution environment. And what I mean by that is um, you have a container, right? And usually you have one container, one app, or one container, one binary. But there are times that you need more than one binary or more than one app for your actual application itself. A really good example of that, well, a really bad example of that is PHP, where you might have like Nginx and PHP FPM. And they would usually communicate over a Unix socket on a Linux machine, right? And so your first attempt might be to run two processes in one container, and that way they can just access it. But that's like I'm not going to say it's a bad practice, but it's a smell when you have more than one process running in a container. So what pods do is they make your networking and storage stacks available to more than one container. And so that means instead of shoving two processes into one container, you have two containers that share the important bits. So they share the network, so they can communicate over localhost if you do network communication. They also share storage, so they can communicate over a Unix socket if they use a Unix socket. And if either way, it's not actually going outside of the pod, right? Because you're using localhost or a volume. So you're not adding any extra weird communication to it or anything like that. So that's basically what a pod is. And so what a sidecar container is it kind of expands on that and says, I can attach a container to your pod to modify the behavior of your pod without you having to modify your application. So an example of that might be you have something that needs to collect metrics, like Prometheus. If you run MySQL, there is no endpoint for Prometheus to scrape. So there's a MySQL metrics exporter, which can be run as a sidecar that will collect the MySQL metrics in the way MySQL expects it, and then expose it as a metrics endpoint in the way that Prometheus expects it. So it kind of acts as a bridge. And so the Istio or Service Mesh sidecars effectively do that, but for the networking. So one of the examples with Service Mesh is doing MTLS communication from pod to pod or from app to app. So normally you would have to build in the MTLS handshakes and communication and trusts into the app itself. What Service Mesh does is it spins up a sidecar in both apps pods, in both apps pods, and the communication happens between those sidecars. And then the applications talk to the sidecar and back just through localhost, right? And that way the insecure traffic is never leaving that execution environment until it's been encrypted and sent over the MTLS connection between the sidecars. And the sidecars are establishing the certificates and trusts to ensure that the right thing is talking to the right thing and is allowed to and has the right encryption.
Yep. Nice. So Fuel Snable asks, so if there was a new partially deployed feature messes up a thing, what can we do to help clean up this mess? So I think that was in reference to the idea of what Istio is and the ability to run partial traffic to it, which in our workshop we will actually emulate, which will be pretty cool. So now that we have an understanding of what a sidecar is and the advantage of one, what is the sidecar that Istio uses, Paul?
So I think it uses, what's the load back? Envoy?
Envoy. Yeah, there we go.
Envoy.
Good.
Yeah, I got it.
I almost called it Ergo Proxy by accident, and if you're really nerdy like me, it's an anime from Japan called Ergo Proxy. But in my mind, it's what that. But you're right, it's Envoy. So, yeah.
Cool story.
Yeah. Right. All right. But anyway, that did not land how I wanted it to, and that's cool. Let's go ahead and kick this off. Story of my life. All right, here we go. And here is a OpenShift cluster right here. I'm logged in. This is on the IBM cloud. And I have the workshop instructions on the left-hand side here. I'll make it a little bit bigger so people can read.
Wow, it's so easy to read.
I know, right? So there we go. I'm actually going to make it a little bit smaller so we can make sure the images come out properly.
Is there an option for you to change the resolution? It looks like it's maybe 720p or something.
Let's see here.
Or it could just be my view of it, because I get a different view than what our friends on Twitch see. So actually, that's probably a better question. Folks, if JJ's once again failing to give you adequate quality on his desktop share, let us know and we'll attempt to fix it. If it's completely readable, then 2 thumbs up and we'll keep on going.
And it looks like I'm already pushing the 720. I can't seem to get anything higher. I don't know why.
All right, workshop side looks good. The OpenShift console is a bit small.
All right, so I'm going to go ahead and make that a little bit bigger. There we go. I'll do it this way.
Yeah.
Okay. So as Paul was saying, this is the gist of an open Istio is the service mesh of choice for from Red Hat and IBM. Istio is an open source project, but we're actually going to be installing the Red Hat version of Istio, which allows for some neat little additions, but we'll get to that in a moment. So let's talk about our objectives. As you can see here, our goal is to install the OpenShift service mesh into our cluster, deploy a book info app, which is a sample app that is kind of like the de facto standard when it comes to the Istio learning. We'll play on some metrics logs and trace some services to make some cool looking things. We'll set up an ingress gateway, and then we'll actually do some of that traffic management, such as the A/B testing of the percentage of conversation or traffic we go to. And then we'll even be able to secure our mesh using MTLS, which is pretty cool. Just as you see, here is that Envoy sidecar that Paul was talking about just a moment ago. And we're going to be using the namespace, or actually project, because this is on OpenShift, of Istio system as the actual control plane, and then the project of book info with all the different microservices inside. And we'll see that a little bit deeper here. All this in general, we're not going to have to worry about. We're going to be playing mainly inside of the OpenShift cluster, which is what we're expecting. Any questions so far?
Not so far.
Okay, so we'll keep going. So as you see, make sure that you want to log into the cluster, which is what we've done, which is great. And then we go ahead and make sure that we can actually talk to it. So what I'll go ahead and do is I will take this copy command. I will bring this over here because I've learned this mistake many times. I will go ahead and copy this over here. Y'all can't see this for obvious reasons because somebody decided to try to steal my credentials recently. I'm looking at you.
Me? I, sir, have never tried to steal your credentials.
There you go. All right. So
I have my own credentials, which
that's true.
are way better than yours.
It is true, actually. All right. And so if we do OC projects, we'll go ahead and see that we are logged in. I will make that a little bit bigger so we can all see it. And being this is OpenShift and this is OpenShift, so OpenShift, you'll be able to run these exact same commands if you have on something like Rosa, which is the Red Hat OpenShift on AWS, or Arrow, which is Azure Red Hat OpenShift. So because OpenShift is just OpenShift, you'll be able to run all these wherever you need to run, or where you're attempting to run this.
A quick note about that is like OpenShift does take a fair amount of resources to run, but if you just want to fudge around with it for a couple of hours, Rosa and Arrow are perfect because you're only paying for the resources for a short amount of time. And you can get like pretty small VM sizes. And, you know, you end up, okay, you're going to run like 7 VMs to run OpenShift in like a minimal way in Rosa. But the reality is, if you're only doing it for a couple of hours to fudge around with something, it's still only tens of dollars. So it's not that big a deal. And so like a month of it is going to be, you know, a couple of $100, and that's something to think about. But a couple of hours or a day, like for most folks, like you can just not sweat it. And then you can always use the IBM Cloud OpenShift service, which is what JJ's using. And JJ will throw credits at you because he's a nice guy. And that way you can get it for free.
That's a little. There's some caveats to that one.
Well, yeah, there's some caveats to it, sure, but you know, he's a nice guy. If you need OpenShift, JJ will help you
out. Okay, cool. So we're going to be playing with some Elasticsearch, some Jaeger, which is the tracing. Kali is actually the observability on top of the microservices. This is usually what gets most people interested in Istio when they actually see the advantage of Kali or Kali or however they pronounce it, because all of a sudden the incantation of microservices starts making some sense. And then, of course, the Red Hat OpenShift Service Mesh.
Yeah. Phil Snabel just made the comment that forgetting about your cluster for a month can be a little bit shocking when it comes to getting the Amazon bill. Absolutely. One of the things I have set up is a cron job that deletes any ROSA clusters that runs every night. And so the worst case, I've got a 24-hour cluster bill.
All right. So the first thing we need to do is install some operators in here. Paul, while I'm installing these operators, you want to talk what an operator is to our audience?
So an operator is a way to extend Kubernetes with your own custom software. And so usually that is things like Elasticsearch or, you know, even Service Mesh, right? Where it is something that adds features to the Kubernetes cluster itself and kind of extends the Kubernetes API to include those features. So in this case, the Elasticsearch operator will basically allow you to say, hey, Kubernetes, give me an Elasticsearch. And Kubernetes will be like, oh, I don't know what to do. Oh, but you have an operator for it. So I'll just throw this request across to the operator. And the operator will go, cool, I know how to do this. And it will spin up your Elasticsearch that you requested. And it will maintain it. It will help you with upgrades. It will help you with fault remediation and stuff like that. And then when you're done with it, you just delete the Kubernetes resource and the cluster will be deleted as well. Super useful if you want to provide things as a service in your cluster. And also some people will actually write operators for their own apps. And that's sort of use your best judgment how deep you want to go into operator land, because sometimes it takes more effort to write an operator than it does to manage a couple of YAML files. So, you know, use the right tool for the right job.
Exactly. That is the, what is it? That is a cloud native mantra that's slowly but surely becoming the right thing to say to everybody. Use the right tool for the right job. Don't try to shove a round or a square peg in a round hole.
Right.
You're just gonna have a bad day. And there we go. So as you can see, I've just been clicking through all of these installations for the operators. Now, excuse me for a second. Now, I did have to do some clicking to make this happen. There is some other ways of doing it, but this is the way to actually see the operator hub, which is this side on the administrator view that it gives you a whole selection of different operators to be able to install and play around with. If you do use something like Rosa or IBM or ROX, Red Hat on IBM Cloud, you have Operator Hub enabled in there inside, so you can actually look for the different what's the word before curated operators out there, so you can actually play around with things. So if you have like MongoDB for your app or whatever, it's pretty easy to find it. I strongly suggest taking some time to look through it.
Yeah, and as JJ said, like he's clicking through, but you can absolutely throw YAMLs at Kubernetes to request operators, and that way you can like GitOps your operators. So if you have multiple clusters, you always want the same operators. There are ways to make it easier to do it, so you're not constantly clicking around in the OpenShift GUI. And I think you create an operator group and a subscription is basically the two resources that will tell it to install an operator for you.
And because this is Kubernetes in its desired state, after me giving those desired states, as you can see here now, we have the installed operators. And I was able to do these one after another. I didn't actually have to do that in order that it was suggested. This is just desired state. But as you can see, we got our Service Mesh, Kali, Jaeger, and Elasticsearch. So now we need to create something called a new project. And the project is, you know anything about Kubernetes, it's a supercharged namespace. There's some really awesome things you can do with projects. We can go into those details at another time. So we need to create something called Istio System. Did I spell that right, Paul? Istio System. I did.
Yes, Istio system. You could always copy and paste.
I could, but that would require me to think ahead. So we'll go ahead and go to projects, and then we'll go ahead and go into this one. Yes. Okay, navigate to the operators to installed operators. Select Istio System from the project menu. Click on the service mesh here.
So one of the things that makes Red Hat Service Mesh a little bit special is it allows you to actually run more than one service mesh on a cluster.
Wait a second.
So,
really?
Yeah, absolutely.
Oh, I didn't know this. Tell me
more.
more.
Yeah. Well, so I mean, there's not a lot of detail to go into before we fall down a huge rabbit hole. But if you have like a cluster that's shared by multiple business units, they might need to have service meshes administered in different ways. And like the default service mesh Istio, if you just deploy it by itself, it basically owns the service mesh for the whole cluster. So now everything has to follow its expectations. With Red Hat Service Mesh, you can deploy 2 service meshes, one for each business unit or however you're breaking it down. And that business unit can be their own administrator of that service mesh and make their own decisions for that, and only see their own stuff in Kali and stuff like that. And so ordinarily, that stuff would be automatically deployed to the Istio system if you were just using straight Istio. Whereas here we could have created it in a different namespace if we wanted to, and we could create it in multiple namespaces if we wanted to.
Got it.
So out of scope of this conversation, but also kind of interesting that, we're trying to figure out the actual real world use cases and make sure they apply, because often the upstream community expectations about how people use things and then the actual way enterprises want to use things aren't always the same. And so one of the things Red Hat does with OpenShift is it tries to find a happy medium between what the original authors intended and then what the actual users expect.
And if you saw that as Paul was talking, this is live and it is up to date. As you can see, different portions of that Istio system are coming online. We've got pretty little green or blue circles going on, and everything it's just kind of coming together, which is exactly what we're hoping for.
Wait, is it already done?
I think.
Did I literally talk for long enough that it finished deploying?
I think it did.
That's pretty cool.
It is, isn't it? All right, and as you can see, that's what I did is I created the service mesh control plane. So now this cluster actually has the control plane inside of it, which is good. So, but now we need to create a member role. So we need to actually tell that control plane, hey, go ahead and take care of this. So we'll go ahead and go into the installed operators, and then the member service mesh under the details tab. Server membership role, create an instance, click the YAML view, click the, and I'm a professional speaker, isn't that great? Go ahead and copy this right here. We'll go ahead and delete this and paste that in there. And as you can see, the members is going to be book info, which is what we're going to be doing. And we're going to go ahead and hit create.
And again, while JJ is doing this, important to remember, like we're clicking through the GUI because it's easier to follow when you're doing something like a presentation and you're demoing something. But you could totally be doing this through your console, through Linux with a kube config and just kubectl applying a bunch of stuff.
So this is the book info application. If you've never seen it before, there's a Python front end to a Java application to a back end of Node.js and another details for Ruby. Yes, it is bonkers if you think about it, but that's the beauty of microservices. As long as you have a shared contract on where your application talks, you can have 4 different languages in your stack now. Not everything has to be just Java or Node because it's containerized, run as a pod container inside of a pod on OpenShift, and OpenShift doesn't care as long as it can run its application.
And this is totally normal, especially as you're decomposing a monolith. Often that monolith may be in, say, Java, and then you're writing, you're strangling it out using whatever makes sense for the particular component you're strangling out. Like if it's super front-end focused, it might not make sense for it to be Python. But if there's lots of batch processing and stuff, those things may be really well done as Python. And so that's why this polyglot approach is good. And what Service Mesh does, it actually allows you to it actually enables that polyglot approach, because some things that you would be having to solve in the language and in its libraries, you're solving in the Service Mesh itself. And so the language specific requirements to have one app talk to another are much reduced.
So just because I'm a good internet user, instead of just doing an OC apply for a YAML file, I'm actually going to take a quick little look at this file to make sure that it is actually what we expect it to be. This is book info. There is a version of it it is a fork. It's not of the original Istio one. It's done by this company named Mantis or Mantius or something like that. But the most important part is this sidecar Istio.io inject true is actually what enables Istio to do its job, which is really cool. And we're going to verify that it's there, what we expect.
So how does Istio know how does that work? I set an annotation and a sidecar shows up? What's going on in the back end?
That's a great question. I don't actually know. Last time I checked, it was just the annotation. And when the annotation's there and when OpenShift starts spinning up the containers, because that annotation is there, it talks to the control plane, and it's like, oh, this is supposed to have the sidecar here. Let me shove that sidecar in there.
Right. So let me answer my own question then.
There you go.
So the way that works is Kubernetes has these concepts of admission controllers, and admission controllers will look at the resources being requested and will validate them. And so you have or change them. So you have a validating admission controller and a mutating admission controller. And so in this case, it's passing through a mutating admission controller. And that mutating admission controller actually looks for pods that have that specific annotation. And if it has that specific annotation, it shoots it across to the webhook. And the webhook will be, oh, you're asking for a sidecar. Well, I know what a sidecar looks like. And so I'm going to stick an extra container in your resource request and then send it back to Kubernetes. And that's how you get from just a short annotation to getting an extra container in the pod. It's also commonly used for doing security requirements. So is it Gatekeeper?
Sounds
JJ?
right.
Gatekeeper, the thing that uses OPA files to enforce security rules, that uses validating ones.
So as you see here, as Paul was saying, I have now spun up our application, our stack I have the version 1, 2, and 3, just like that image I showed earlier, and also the different applications running as pods inside of it. And as you see, it's 2 of 2. Back to what Paul was saying about the Envoy being injected in there also. If the Envoy wasn't there, it would have been 1 of 1.
So why don't you go ahead and do a KEdit Pod Details V1.
There we go.
And let's have a look down to basically you're looking at the containers list. Just do one more. Slash enter. There. Keep going. There it is. There's your spec. And so you see the first container is the book info one. So that's the one that we provided. And then if you look for the next dash image, it starts at args. So this where it starts at args is the second container, and you can see there it's calling the proxy, all the proxy bits. If you look down at the image name, it'll be something about Red Hat. Really, image colon. Yeah, so registry, blah, 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 OpenShift Service Mesh, blah. So basically that's the section that is being injected with that annotation.
All right, and that means we've successfully gotten our book info up and running. But hey, we need to actually see it work first. But we haven't, because we haven't exposed anything. If you want to come into the GUI, if you don't believe me, I can go into book info here.
GUI.
Go to the developer, and here is just a great representation of it. But because we don't have a route to it, or we haven't exposed it to the internet yet, we have our application running, so we need to open it up, and that's where we create the ingress gateway and route here. All right. So what I will go is I will go here, and the first thing is to create the ingress gateway, and there we go. It's another YAML file, but that's okay. But we should be able to see something change over here also here in a moment. We'll come back to that in a second. And then we will get the route here. There we go. And we need to take the ingress host right here, copy that to export ingress host equals this, and if we click on go to this / product page, there we go, and here is our actual book info application now exposed. And as you can see here, because we don't have any rules, we're just load balancing between it. You'll notice that the stars will change here in a moment. So if I refresh, there we
Enhance.
go. There's no stars.
Enhance.
There's red stars.
Enhance. It's not working.
No. Okay,
there it is. So, now I can actually see what's on the screen.
Yeah. So there's 3 different versions, version 1, 2, and 3. 1 is no stars, 2 is black, and 3 is red. So we are flipping between it because we have we're just load balancing between it 1 to 1. But it's important to know that.
So what are we? Sorry, what are we load balancing between?
These 3 different versions: version 1, 2, and 3 for our application.
Of one of the microservices or of the app, like.
Yeah. Hang on. Let me bring up the chart right here. So as you see, that Java application had reviews 1, reviews 2, reviews 3. Reviews 1 has none, 2 black, 3 red.
Okay, so the users coming in, they're hitting the Python, which is like the front end.
Yep.
And that is then reaching out to the back end, which is either Java or Ruby, depending on if it's the reviews or the details.
Yep.
And then the Java is reaching into Node to get the actual ratings, so the stars.
Correct.
Right. And then we can see from the thing, reviews V1 has no stars, reviews V2
Mhm.
has black stars, and V3 has red stars.
Yep.
Gotcha. And so right now it's just doing like a fair load balancing across the
Yep.
three. It's not really being specific.
Yep. And there we go. So the next step is to actually start playing with the telemetry and actually seeing how this all happens. So what we'll do is we will go ahead and do the Grafana thing. So what I'll do is I'll start throwing some traffic to our. Oops. I'm gonna, because I don't really like how long this sometimes this can take, I'm just gonna throw a bunch of them at it. So now we're hitting it pretty regularly. So what we'll do now is come back over here, and then inside of the OpenShift Web Console, click on networking. So when you go back to administrator, networking, we need to go to
Networking.
Oops, thank you. Networking routes. You select the Istio system. You need to find the URL for Grafana, which is this one. I'm going to log in with OpenShift here.
So here's another thing that Red Hat does for OpenShift is it makes sure that all these things are like properly integrated in, and that includes things like authentication. So ordinarily, when you deploy a Grafana, you just get like an admin username and password, right?
Mm-hmm.
What OpenShift does is like, well, you already are authenticating to the OpenShift cluster, so let me just force you to re-authenticate, and then we can also check that you have access or should have access to Grafana. And it does that by making sure that your user has RBAC that gives you access into the namespace in which Grafana is running. And so if this was like, if there were two business units using this cluster, you could do it so that business unit B couldn't access business unit A's Grafana, and that would all be done by magic with Kubernetes RBAC by the OpenShift administrators.
So here we go. Here's our product page, and this is actually now live. We're updating every 10 seconds of us slamming into our back ends right now, which is pretty cool.
Sorry, it's doing what to our what?
It's hitting our back ends right now, which is pretty cool.
All right.
Yeah, there you go. I was trying to be clever, and it didn't work. That's fine. As you can see here, we've got our response codes of 200 coming in, and then 304 has not happened, which is expected, which is pretty cool. And imagine now if you have your normal application out in the real world with no setup, I got all this information to be able to see what our actual application is, the health of our application using Istio. Cool. You can click around inside of these. You can take a look at the ratings if you so choose. As you can see here, it reflects it more or less the same. And then the details page here too. But there's some interesting information that.
So is this doing like automatic tracing? Like, how is it getting this information?
That's well. This is just getting us information directly from the Envoy proxy. We haven't actually gotten to the tracing yet. This is just giving us the stats of what's happening. As you can see, the percentage 99, 50, and 90% of the how long it takes the request. This one is the actual response code. They're all coming in as 200s, which is what we were hoping for. And then how many operations per second. There's a few other things in here too. Talking to MTLS and things like that, but it's all out of the box, so you don't have to build any of this, which is the main value prop of all that. All right, so now that we've actually seen these really nice information, let's take a detour over to Kali again. So we've got neat graphs that we can put up on well, I mean, it's a web page, I guess, but you can put it on your site to make sure everything's going how you expect it to. Kali comes in and really does ramp up something really awesome for you. So we'll go ahead and bring up Kali here. And it loads. We go ahead and log in. And hopefully this is still going. Yep, still going. this will, as you can see here, there is already traffic happening, which is what we're hoping to see. So we'll hit the graph right here to actually see the graph of our communication. And here it is, real time, what our communication is going back and forth. It updates every second to see where things are hitting, where everything intertwines inside of it. So you actually see the microservices talk to one another. This right here, you can do some really awesome things going on. I can actually change this to requests per second. Here we go. And as you can see here, there we go. We got actual numbers on how many requests per second are going to the different things. Back to how often these change, because we're just hitting each backend one after another after another. We haven't changed the traffic shaping at all. Everything's loaded down to one second because it's hitting 1, 2, and 3, which is pretty cool. So with no overhead at all, we already have this much information and observability built in because of Istio. All right. Okay, let's go ahead and move into some traffic management. This is actually when we start playing traffic cop, leveraging Istio to start giving us traffic to specific backends. If you didn't know what A/B testing is, Paul, do you want to give us a quick rundown of what A/B testing is?
Let me A/B testing. So A/B testing is when you deploy two versions of the same application and you select a percentage of traffic to go to the newer version. And that allows you to validate the changes you made with like a small sample in production. So you're getting real world workloads.
Yep.
Is that right? It's also often called like blue-green deployments and stuff like that. Is kind of the same basic idea.
And so what we're going to do is we're going to just pull directly from this example here and create some destination rules, which is what Istio needs to know to be able to deploy to the different portions. So we'll go ahead and do that. And while that happens, I'll go ahead and just bring it up anyway to make sure. wget this http:// Right. We'll go ahead and just bring this up to make sure that it's what we expect it to be. As you can see here, it's just mapping some versions to different things. Here's the destination rule to the different backends. Don't worry if you don't understand this right now. We will be playing with these here in a moment. All right. Now we're going to create a virtual service, which applies to the host needed. Each routing rule defines matching criteria for the traffic in the specific protocol. If the traffic is matched, then it will send the name destination service defined to the registry. So this is just now giving a little bit more information around it. So we're going to send everything to V1. If you want to take another look at this real quick, I will go ahead and wget. And we'll go ahead and bring the virtual to V1. At the very bottom here, as you can see, the HTTP destination rule is just going to V1. So if we go back to our book app, if you remember correctly, V1 is the one with no stars. We have some stars right here, right now. And I'll go ahead and refresh, and there's no stars. So there we go. So we now know that we have now told Istio only send me to V1. So if I take this one step farther and go ahead and for loop this guy, go ahead and hit it, making a liar out of me. There we go. We can actually go back into Kali here and refresh. And as you can see, because we don't have any of the ratings, we are not actually getting all the way to the ratings or the reviews because it's only going there. Hey, Feznuts, how you doing, buddy? Kevin, you doing okay, man? Everything good? I hope you're all healthy. As you see here, we're just in the back end as we expected. Okay. I'll go ahead and stop that.
I'm sorry, did you just call Kevin Peznuts?
I did. This
I
is
think
this
it's
is
Pesnorts.
oh,
I feel
whoops.
like the A makes for a very important distinction.
My bad.
Yeah, yeah.
My bad. All right. So now that we all only get to version 1, we'll go ahead and do some A/B testing here. We're going to go ahead and send the traffic only to Firefox on V2. So you can actually just take this right here. And as you see this user agent right here, which is the most important part, it regexes for Firefox. Now, take that one step farther and say, for instance, you run an application and you wanted to test a new version for iOS and you wanted to go through like Safari on iOS. You can change that user agent to that specifically to regex off of that. So you can now just test going to this specific service, this specific microservice that runs on iOS, for instance. It opens up a really strong possibility. So
the other thing you can do there is in a lot of browsers in developer mode, you can change the user agent. So you could actually change it to something like my internal dev Firefox. And that would mean that just your browser or your team's browsers that are setting that agent would see the new version, and all of your customers would see the old version. And so that's where you can kind of get into some fun little tricks, so that maybe you're live testing it, with yourselves versus like your actual paying customers.
Yep.
But it is cool, right? Because it's actually, because you think about that, it's inspecting the actual HTTP headers and is deciding based on the headers you're sending through. So I guess you could even send a custom like organization header or something else to say, hey, this is destined to hit the test endpoint instead of the real endpoint or whatever. So it opens up some really interesting.
Exactly. Exactly. Like it allows you to, it empowers you to do testing with real data, which is usually the biggest challenge when you're bringing out a new feature. Just to reiterate again, as you can see, this is Firefox and it is coming into black as we were expecting. And then our Istio on Safari here is red.
JJ, now if we're doing this, we're kind of doing deploy and then test. And does that mean your misuse of CDCI actually becomes the way we're actually doing it? We're deploying and then doing our tests?
Exactly.
So finally, JJ's correct when he says CDCI instead of CI/CD.
That's right. Right. You got me. You got me. Why do you think I like Istio so much? It forces me to do it the way I understand. Awesome. All right. So let's move on to a Canary deployment here, where we can actually send 80% of our traffic to V1, which will be pretty cool. So instead of just doing through user agents, we are now actually telling a specific percentage talking to our backends.
Now, JJ, I want to step back. When you asked me what A/B testing was, I think I described what canary testing is.
Oh, shows how
So,
much I was actually not paying attention to
right?
what you're saying.
So when I was explaining A/B testing, it was actually canary testing I meant, because that's getting more. That's more like the blue green style that or is it red black? What is it? What's the Netflixy thing? They say red black, right? Because it's the Netflix colors.
Yeah, that sounds right.
And the rest of the world says blue green because we like to annoy colorblind people.
So as you can see here, 80% of our traffic is going to V1, which is what we're expecting. And then 20% is going to V2. I believe I still have something running, hitting it, which is the reason why that's not exactly 80%, but it's good enough. And then with just taking that very simply, we can go ahead and route everything to version 3 via this one. And we can do wget, and you'll notice the weight will be 100% or 100, which is what we're expecting, or didn't even have a weight. They just removed it. The last version I did this, they had a weight version in there. But now we just do version 3. If you remember, version 3 is just red. And there we go. So every time we hit our backend now, we get red. Okay, cool. So believe it or not, we're actually really far into this workshop. We've done some we've shown some really interesting things here. Now we're actually going to play with some SSL. 9 out of 10 times. Thank you, TLS. We're going
I
to
don't even know
configure.
what's the difference. TLS is just newer, right?
Yeah, it's
But we
newer.
just say SSL because we're old and stupid.
Exactly.
Right.
I still assume OpenSSL runs the world. All right, so here we go. We're going to go ahead and configure MTLS. You'll need to modify the previous destination to rules to use Istio Mutual. So we'll go ahead and grab that, and then we will bring this over here and install that. So there we go. We had replaced a few things, which is what we're expecting. Now everything should be working as we expect, which is what we always hope. So I'll go ahead and refresh this a couple times. Okay, looks like it's pretty good. Now, if we come over to Kali here, as it said, go to book info, under display, select security. So we'll select security here. And there we go. We now have some nice, pretty little locks here to say that we are actually talking to V1 and should be MTLS enabled lock icon on the right pane, which is what we're expecting. So now we're actually talking MTLS inside of our cluster, which is legit cool when you start thinking about it, because that means you truly are certificate secured between microservices now, because we're leveraging the Envoy proxy to do that. But we're not actually doing it from the outside. So we're talking internally, nice and secure. But if you didn't notice, it says it's not secure because, well, it's not secure. Luckily, Istio does this for us. So what we'll go ahead and, here we go. We'll go ahead and change our ingress gateway to an edge termination, and then turn off insecure to no traffic. So we'll go back into the networking routes here. We'll go to the Istio system project, and then create route here. We'll call it Istio Ingress Gateway Secure the service. Istio Ingress target port that secure route edge termination, and then do not allow any insecure traffic. I'll go ahead and create that. Now, we'll go back to routes here. And here we go. Here's our secure. Go ahead and bring that up. And product page. And there we go. We've got now secure SSL communication from OpenShift on the edge too. So no communication now inside of our cluster is insecure. Pretty cool. And if you've ever played with TLS or SSL, because I'm old, and had to do this is usually a huge pain point. But being that we're leveraging Istio, it's already there. You just turn it on and it makes it happen.
I didn't see you accept like a untrusted cert. So is it magically using a trusted cert?
Yeah, it's leveraging from the app domain cert here, where it's now pushing it over the edge to HTTPS for the cluster for OpenShift. So
cool. So I guess that's probably the Red Hat side of the of the service mesh. Is probably Red Hat is smart enough to say, hey, we already have official certs for the cluster of apps, so we can just reuse those certs for the Istio secure route.
Yep. That sounds exactly right. It just leverages everything for us. And as you can see here, again, everything is nice and secure inside of our application. Okay. And that's pretty much it for this workshop, which is actually smack dab to where we wanted to be. Nice. The rest of it's just cleaning up everything And if you ever wanted to see any sort of related content, it's here too. But that's not too big of a deal. Let's see here. We'll bring our names back up here, so in case anyone's just catching up here. So Paul, do you feel like you
Hi.
learned something?
I did learn something.
What'd you learn?
I learned that Istio and Service Mesh actually works.
Exactly.
I mean, I've messed around with Istio before, but not in quite some time. And I have deployed the Red Hat Service Mesh operator, but I've never actually done anything with it. So seeing it just happen and work as expected was cool.
And Colton XL, yes, you are right. By default, I believe everything is pushed in through Let's Encrypt when it comes to this.
Yes. So actually, I don't know about on IBM Cloud, but in general, the managed OpenShift use Let's Encrypt for the default cluster certs, but it's not managed by Cert Manager. It's managed upstream of OpenShift as part of the Red Hat SRE/management tooling that wraps around OpenShift to create the managed services.
Yep. If you've never heard of a Cert Manager, Paul and I have a few streams in the past that we spent some good amount of time with Cert Manager. It is as soon as you can figure out the right incantation for it, it really is rock solid, and it will just take care of your application on Kubernetes or OpenShift for that matter, with very little overhead if you want to go down that path. Cool. Well, Paul, you got any last words to say anything? Because I mean, this is smack dab where I wanted to end it.
Last words? Do you know something I don't know?
Well, we're gonna be on a plane next week, so we're not gonna be streaming. That's for sure.
Oh, are we taking a break next week? I was actually going to ask about that.
I mean, we could try to stream from KubeCon.
No, the correct answer is for you to say we're taking a break.
Okay, we're taking a break. All right, cool.
Cool.
Works for me. All right. Well, say bye, Paul.
Bye, Paul.
Bye, everybody. Thanks for sticking around.